I want to talk about using substitutions to solve first-order differential equations. In these, you will be given a substitution. You're not expected to find a substitution for yourself, and then you just follow through logically until you find the answer. Let's do an example just to see how this works. Use the substitution v equals y over x to solve this equation. dy by dx is x squared plus 2y squared divided by xy. Well, they would normally give you this substitution, v is y over x. I think it's far better to rewrite as y equals vx. We want dy by dx, so let's find dy by dx. This is the product rule. V is a function of x. We can see that from the fact that v is y over x. So we're differentiating this with the product rule. Differentiate the x, we get v plus x, differentiate v. Now let's put everything into the differential equation. dy by dx is v plus x dv by dx. X squared is still x squared. Y squared is v squared x squared. And on the bottom we have x times xv, or vx, whichever way around you want. X squared now will cancel, and this leaves us with 1 plus 2v squared divided by v. Subtract v from each side. 1 plus 2v squared divided by v. Subtract v. Well, if I subtract v, that is v squared over v. And that gives me 1 plus v squared divided by v. Now we have a nice simple equation where we can separate the variables. This will give us v divided by v, 1 plus v squared, dv is 1 over x dx. We should be able to integrate both of those quite easily. The left-hand side, it looks like a log. Yes, it is. Log 1 plus v squared. Differentiate it. 1 over 1 plus v squared times 2v, I will need a half. Integrate 1 over x, that's log. And I'm going to put my arbitrary constant in as log a, which is nice. And because of the half on the other side, I'm actually going to put it in as a half log a. It just makes the algebra a little bit sweeter in the next line. You could put plus c, but certainly plus log a is a little easier to use. If we multiply through by 2, we get log 1 plus v squared is 2 log x, or log mod x. That is log mod x squared. Multiplying by 2, that's log a. Now I can write that as log a x squared. And now I've got log equals log, so I have 1 plus v squared is ax squared. Well, having got that, and now I'm in a position to change the v back to y's and x's. V was y over x. 1 plus y squared over x squared is ax squared. Subtract 1, and you've got y squared over x squared is ax squared minus 1. Multiply by x squared, and you get y squared is ax to the 4 minus x squared. So it's what I said at the start. Put the substitution in, follow through, and you should find an equation of a sort which you can solve fairly easily, and then you've got your answer. There are lots of different substitutions which you can use. I don't propose to teach you about each one. I think you should get used to seeing a substitution and working through the question for yourself rather than reproducing something that I have given you with different numbers in.